Note: one of the early triumphs of the KMT break was that it was able to provide an explanation of effusion and also diffusion, which we will talk about shortly. Stop. One of the early triumphs of the KMT was that it was able to provide an explanation of effusion and also diffusion, which we will talk about shortly. Question: effusion is defined as the process by which a gas escapes a container through a tiny hole, break, into an area of lower gas concentration. But for the purposes of these notes, we shall say a blank space. Stop. Answer: effusion is defined as the process by which a gas escapes a container through a tiny hole into an area of lower gas concentration. But for the purposes of these notes, we shall say an evacuated space. Typically, this evacuated space is another container, or more likely, a separate chamber within the same container. Question: in the year blank, Thomas Graham studied the time it took a fixed amount of various gases, break, to effuse completely from one container to another. Stop. Answer: in the year 1846, Thomas Graham studied the time it took a fixed amount of various gases to effuse completely from one container to another. Question: his observations, which is now known as Graham's law of effusion, states the following, break. The rate of effusion of a gas is blank to the blank of its blank. Stop. Answer: Thomas Graham's observations, which is now known as Graham's law of effusion, states the following. The rate of effusion of a gas is inversely proportional to the square root of the gas's molar mass. Or we could say the molar mass of said gas. Question: expressed mathematically, this equation is as follows, break. Rate of effusion of gas X proportionality sign, blank, stop. Answer. Expressed mathematically, this equation is rate of effusion of gas X, proportionality symbol, 1 over the square root of italicized M, or capital M rather, italicized capital M, R sub X.